Here are the solutions to problem set 3. I know this assignment was pretty lengthy, a lot of problems, a lot of work. The problems I already went over in the lesson, I just have the answers showing up here. I'm not going to go back over those, but you can still see just in case you didn't happen to write them all down by watching the lesson. All right, so for 1, 2, and 3, we just had to find the missing side. So this just requires the Pythagorean theorem. There's no indication that these are special right triangles, so just to show the work for this. In number 2, we have the two legs here, so we're just going to say 9 squared plus 3 squared equals our hypotenuse. I'll just call that c squared. 9 squared is 81 plus 9, so this will give me c squared is equal to 90. And then c is just equal to the square root of 90. I could simplify that by saying that this is 9 times 10, so c is equal to 3 radical 10 is the exact answer, and then this is approximately 9.49. In number 3, we have one leg in the hypotenuse here, so we're going to write this as 2 squared. I'll just call the missing leg b, so we'll say plus b squared equals 2 radical 5 squared. So we're going to get 4 plus b squared. Now again, when I go to square this quantity, it's just saying 2 squared, which is 4, and then radical 5 squared, so radical 5 times radical 5 is just 5, so I'm getting 4 times 5. So I have 4 plus b squared equals 20. Subtracting 4 from the 20, we'll get b squared equals 16, so our missing side is just going to be 4. Now for 4, 5, and 6, we have to find the missing angle measure here, theta. So we don't need, it's not necessary to find the third side. We have enough of information just to set this problem up. So in number 4, based on where theta is, the 5 is the side that is adjacent to our angle, and then 16 is the hypotenuse because it's across or opposite the right angle. So adjacent over hypotenuse, we have to go back to SOHCAHTOA. Adjacent over hypotenuse is the cosine trig function. So I'm going to write this as cosine theta is equal to adjacent over hypotenuse, so 5/16. And then you were doing this back on problem set 2. We would write this to find theta is equal to the inverse cosine of 5/16, which is approximately, we'll round to the nearest hundredth here, 71.79 degrees. So there's our missing angle measure. All right, in number 6, because we did number 5 together, here's theta. The 4 is the side that's opposite. The 9 is adjacent. So we're going to have tangent is equal to opposite over adjacent. So we'll say tangent theta is equal to 4/9, opposite over adjacent. So then theta is equal to the inverse tangent of 4/9. And all we have to do is type that into our calculator. So theta is approximately 23.96 degrees. All right, for the next quite a few problems here, we have to solve for the entire triangle. So again, when it says solve the right triangle, we're trying to find everything else that's missing. We did number 7 together in the lesson. So let's take a look at 8. Now, if you notice here, again, one angle is already 90 degrees, a right angle, and then in number 8, we're given angle A, so we could quickly find angle B. So the measure of angle B, because all 3 angles in a right triangle add up to 180, well, if C is already 90, we can get that 90 out of there and just say that the other 2 angles also have to add up to 90. So all we have to do is say 90 minus 25, which will give us 65 degrees. The measure of angle B is 65 degrees. Next, we need to use a trig function to find one of the missing sides. Because we have 2 missing sides, we can't use the Pythagorean theorem. It doesn't matter which one. I'm just going to go ahead and find side B next. So I'm basing this off of angle A. So the 8.5, this is opposite. And then the side that's B here is adjacent. So again, opposite over adjacent is tangent. So I'm going to set this up as tangent of angle A, which is tangent of 25. Is going to equal opposite, which is 8.5, over adjacent, which is B. So now I have some work here. Since B is in my denominator, I'm going to go ahead and multiply both sides by B. And this was a shortcut I was showing you at the end of the lesson. We could always do this, but in the end, it just turns out that we really end up switching tangent of 25 and B. So I'm going to get B times tangent of 25 is equal to 8.5. Now to get B by itself, I divide by tangent 25. So B is equal to 8.5 divided by tangent of 25. Now I could just type that into our calculator. So B is approximately 18.23. All right, now to find C, we could go back and use another trig function, but we're already rounding here, so it really doesn't matter. But now that we have two of the three sides of a right triangle, we could just use the Pythagorean theorem. So B is going to be 18.23 squared. A squared is 8.5 squared is going to equal C squared. So squaring these two, adding them together, I get about 405.3125. Taking the square root of that, C is approximately 20.13. So we have the value of C, we have the value of B, and then we have the value of angle B. So those are the three missing parts of this right triangle. All right, looking at number 9, very similar. So I have angle A is 68 degrees, so I could find the measure of angle B next, which is just 90 minus 68 degrees there. So this will give me 22 degrees for angle B. Again, it doesn't matter what I find next, but based off of angle A here, side A is the opposite, and then I have this side, which is 5, which is the adjacent. So I have opposite over adjacent, which again is tangent, so I'm going to say that tangent of 68 is going to equal opposite, which is A over 5. So now my variables in the numerator, all I have to do is multiply both sides by 5. So side A is equal to 5 times tangent 68. Typing that into the calculator, A is approximately 12.38. So I have angle B, side A, we could use the Pythagorean theorem to find side C. So we could say C squared is going to equal 5 squared plus 12.38 squared. This gives me 178.2644. And then taking the square root of that, getting about 13.35. All right, now in the next set, we're not given a picture, so it's going to be helpful just to draw out a picture of a right triangle. I did 3 or 4 of these. Yeah, I did 3 of these from the other side, so you could take a look at those. All right, but for number 10, remember when we go to sketch our right triangle, it's very important to always make the angles show up in the same location. So we always want A and B to be the 2 acute angles, and then C should be the right angle. So here we have A is 32.5 degrees, and then side B, which is opposite angle B, that's going to be 7. And then I could label this as side A and side C. So again, I could go ahead and find the measure of angle B first. That's just going to be 90 minus 32.5 degrees, giving us 57.5 degrees. All right, now I'm going to still base this off of angle A. Even though we have angle B, you could use that. But side A, I'm going to find side A first is opposite angle A, and then the 7, again, is adjacent. So I'm using tangent yet again. So I'm going to say tangent of 32.5 degrees is going to equal opposite over adjacent, so A over 7. So now A is just going to equal 7 times tangent of 32.5. And this is approximately 4.46, which kind of makes sense. Look at how side B is labeled. It's only 7, so sometimes the numbers are very close together. Other times we might find them to be quite different, but still relative to each other, not anything that's too drastic. So it's always good to check the reasonableness of your answer here. All right, so to find side C, we could just use Pythagorean theorem. So we could say C squared is going to equal 7 squared plus 4.46 squared. Getting a total for that, we get about 68.8916. And then C is approximately 8.30. So all 3 values were pretty close together. So what I'm talking about is like we get a 4.46 and a 7. It's not like we're getting something that's like 100 units long here. So they're all very close together. All right, likewise for 12, let's go ahead and just draw a right triangle. Label it A, B, and C for the right angle here. So here we're given that A is 8, so that's the side opposite angle A, and then B is 71.2 degrees. So here we could find the measure of angle A first, which is 90 minus 71.2 degrees. So the measure of angle A is 18.8. Please make sure you're labeling all degree measures for angles. All right, so next we could go ahead, let's find side B. So again, I'm going to use angle B in this case. So side B is going to be the side that's opposite, and the 8 is adjacent. So I'm working with tangent again. So we're going to say tangent of 71.2 degrees is going to equal opposite. So I'm going to get B over 8. So B is going to equal 8 times tangent of 71.2. Which is approximately 23.5. And then to find C, again, we'll use Pythagorean theorem. So C squared is going to equal 8 squared, squeeze this in here, plus 23.5 squared. So C squared is first going to equal about a 616.25. And C is approximately 24.82. Now, even though side A was 8, but B and C were still very close together, so that is still a good indication here. All right, now for 14, which is a lot like the problem we did together, 15, we're given the two sides first, so this changes a little bit, where we cannot start by finding missing angles just yet. So again, I want to label this A, B, and C. So side A is 6, side B is 10. Here we're going to find side C first using Pythagorean theorem. So C squared is going to equal 10 squared plus 6 squared. So C squared is going to equal, this will give me 136. And then C, we'll just go straight to approximation here, 11.66. I didn't necessarily have to find that first. I don't need that to help me with the angle measures here. So I'm just going to choose angle A, and the side that's 6, that's opposite, and the side that's 10, that's adjacent. I choose to use these two because they're nice whole numbers rather than the rounded number I found for C. So again, this is going to be tangent of angle A in this case is going to equal opposite over adjacent, so 6 over 10. Now to find A, this is going to be the inverse tangent of 6/10. So A, measure of angle A is approximately 30.96 degrees. Now all of these should be giving us acute angles that are less than 90 degrees. So we have angle A, and then the measure of angle B is just going to be 90 minus 30.96, so we get 59.04. All right, and a few more of these to go through. So number 16, kind of like the ones before, we're given an angle measure and then just one side. So again, just drawing a right triangle. All right, angle A is 35 degrees. Side C is 6.2. All right, so first we're going to find the measure of angle B, is just equal to 90 minus 35, which will give us 55 degrees. Then we have our choice of which two sides we want to find, so it really doesn't matter. I'm going to go ahead and find side A next. So according to angle A, that's the angle I'm going to use. This is the side that's opposite, and instead of being adjacent, now we have hypotenuse. So this would allow me to use the sine. So I'm going to say sine of angle A, which is sine of 35 degrees, is going to equal opposite over hypotenuse. So A over 6.2. Now to find A, I simply multiply 6.2 by sine of 35. And A is approximately 3.56. Which makes sense because our two legs cannot be longer than the hypotenuse. All right, now to find side B, we could use Pythagorean theorem. So we'll say B squared plus A squared, which is 3.56 squared, is going to equal 6.2 squared. So B squared is going to equal, once I square 6.2, I'm going to subtract the 3.56 squared. So this will give me about 25.7664. And taking the square root of that, b is approximately 5.08. All right, here's a picture for 17. We're given angle B is 14.52 degrees and side B is 7.25. Again, we could just go ahead and find the measure of angle A by subtracting 14.52 from 90, so we get 75.48 degrees. And next, I'm just going to go ahead and find side A. So now I am back to tangent. Working off of angle B, we're going to say that that's opposite here and adjacent. So we're going to say tangent of angle B, which is 14.52 degrees, is going to equal 7.25 opposite over adjacent. So again, this is the case where our denominator is what's missing. And as we saw a few examples back, all I have to do is really switch these two. So A, little time saver here, becomes 7.25 over tangent of 14.52 degrees. So A is approximately 27.99. Even though that looks a lot longer than the picture I drew is just to help us get a nice orientation of where the sides are, what trig function to use. And then finding our hypotenuse here, we'll just say c squared is going to equal 7.25 squared plus 27.99 squared, which, again, just leaving this as c squared for right now, totals 836. We'll say 0.00. We'll just leave it at 26 for right now. So 836.0026, taking the square root of that, getting about 28.91. All right, so two more where we're just given the sides. Going to go ahead for number 18. I already have this drawn in now. So we need to find our hypotenuse. We'll say c squared is equal to 13 squared plus 18.5 squared. Totaling the square of those two numbers will give us 511.25. Taking the square root here, c is approximately 22.61. Now I'm going to base this off of, let's do angle A. Again, I'm going to do tangent here. I want to use these two values, so we have opposite and then adjacent over here. So I'm going to say tangent of angle A is going to be 18.5 over 13. So A is going to equal the inverse tangent of 18.5 over 13, which is approximately 54.90 degrees. Leaving us for angle B, 90 minus 54.9 is giving us 35.1. All right, so pause the video just to show this a little bit quicker now. So drawing the right triangle for number 19, again labeling the two sides that we were given, 5.3 for A, 7.1 for B, just using Pythagorean theorem here. C turns out to be approximately 8.86 units long. Here I'm going to go ahead and off of angle B this time. Again, we have a choice, A or B. Either way, I'm going to use tangent here. So based off of angle B, I have 7.1 as the side that's opposite, 5.3 is the side that's adjacent. So we're going to say tangent of angle B is going to equal opposite, so 7.1 over adjacent, which is 5.3. So then B is going to equal the inverse tangent of 7.1 over 5.3. And we get that B, measure of angle B, is approximately 53.26 degrees. And then the measure of angle A is going to be 90 minus 53.26 degrees, so 36.74 degrees. All right, so those are all the problems where we had to solve the triangles. Now for the last three, we were just using a formula that I showed you in the lesson, and the formula, it's straightforward once we know it. So to find the area, it's simply equal to 1/2, and then whatever two sides were given, we multiply them together. So they could be any two variables here. I'm just going to say x times y, where x and y are the two sides that form our angle, and it's times the sine of our angle. So number 20, area is going to equal 1/2. Our two given sides here are 30 times 12, and then the angle they form is 140 degrees, so I just want to take sine of 140 degrees. And then we want to just type all that into our calculator. So our area is approximately 115.70. Now because this is labeled as centimeters, we'll say square centimeters. For number 21, area is going to equal 1/2. Our two sides that form our angle are 6 times 15, and then the angle formed here is 60 degrees, so we want sine of 60 degrees. So here our area is approximately 12.99. And if it doesn't label it, we just want to say square units. So that's all we have to do when we're looking for an area of a triangle. Notice these are not right triangles, but the height is missing. We use this formula. Likewise for 22. Now, if we were to draw this triangle, I can get the page to stay here. Again, we want to label it. It doesn't have to look, as long as it doesn't look like a right triangle, it could look like anything. So I'll just have P, Q, and R. So angle Q is what's given here. So this is 160. I could definitely redraw that now because that is not a 160-degree angle. So we're looking more like this. Even bigger yet. 160 degrees is a pretty large or obtuse angle here. So here we have 160. So that's Q. If I go P and R. Again, I just wanted to see the location of the sides. So side P is going to be over here at 20, and then R is over here at 15. So I just want to show you, even though we weren't given a picture, the two sides are the sides that form our angle of 160. So our area is 1/2 times 20 times 15 times sine of 160. And then typing that in, we're going to get our area is approximately 51.3 square units. All right, so a rather long lesson, I know, but please let me know if you have any questions.